Hello everybody. I have upgraded from my last video. I've added a splash screen as well as a new t-shirt. So today we're going to be looking at Palindrome Number, which is LeetCode number 9. Now, Palindrome Number states that given an integer, x, return true if x is a palindrome integer. Well, what is a palindrome? A palindrome is an integer that reads the same backward as forward. For example, 121 is a palindrome, while 123 is not. So let's go through the examples. Example 1 here says 121, which we've already done, is a palindrome. Example 2 is negative 121. It's important to note here that it's actually 121 with a negative at the end. So all negative numbers will not be palindromes. So we need to account for that in our code. Example 3, so zeros are also included, and 0, 1 is not equal to 1, 0. And example 4 is just basically the same as example 2. One thing I will note, a follow-up question is, can you solve it without converting integer to a string? And the reason they do this is because you can easily convert an integer to a string, and string has a method to just reverse the string. And then you just compare the original to the reverse. Well, by not doing that, we're going to add a few more steps, but we will still compare the integers at the end, just not by converting them to strings. So let's get started. My favorite part, the pseudocode. So we have a method, is palindrome. We're going to input the number. We'll immediately return false if it is a negative number, like we talked about. Now we're going to loop through each value in number. We're going to grab the last value in number. We're going to save this value to a new variable called reversed, and then we're going to remove the value from the original number. And then we'll end the loop, and that's pretty much it. We'll compare the original number to this reversed number, and we'll end the method. Now, some questions that you might have. How do you pull the last number out? Well, we're going to use what's called the modulus operator, which is the percent sign, and that will return the remainder. So if you take 321 divided by 10 in standard division, that's 32.1. But if you take 321 modulus 10, it's just going to return the 1. If we keep going here, now it's important to note that the modulus doesn't remove the 1 from the original number. I'm just doing this for demonstrative purposes, and I'll show you how to do that in the next slide. So 32 divided by 10, 3.2. Modulus 10 returns the 2. And then finally we're left with 3 divided by 10, which is 0.3, but the modulus will return the 3. So if you look, we've successfully reversed the integer, 1, 2, 3. All right, now how do I remove the number from the original number? Well, that's very simple. You just divide the number by 10. Integer division will remove the remainder. So 321 divided by 10 is 32. 32 divided by 10 gives you the 3, and then 3 divided by 10 gives you the 0. So when we hit 0, that's when we're going to break out of the loop. So that's important to note that. And then finally, how do you build the reverse number? So we're initially going to assign the reverse number to 0. And then we're going to multiply it by 10 and then add the number. So what does this look like? So the first time through, 0 times 10 is just going to be 0, so we'll just add the number, 1. Now the second time through, 10 times 1 is 10, plus the number 2, 12. And finally, we get 120, add 3, and we've successfully reversed the number and stored it in a new variable. All right, so let's code this. So we have a public boolean is palindrome with an input parameter called num. So it's expecting a boolean to be returned. First thing we're going to do, if num is less than 0, we'll just return false. We're going to assign that reversed equal to 0 like we talked about. And because we're going to be basically chunking numbers off of num, we need to make sure we save it in the original variable. So we'll do that as well. Now we're just going to loop through. While num is not equal to 0, we're going to define a new variable called remainder and make that equal to num mod 10. It's important to note here that let's say you have the initial number 100. If you do 100 mod 10, your remainder is 0. There is no remainder. But that is actually what we want. To reverse 100, the first number you want is 0. So it works without a remainder as well. Then we're going to assign that reverse equal to itself times 10 plus the remainder. And then we're going to divide num by 10 to get rid of the number. We don't want to deal with it anymore. And we'll end the loop. And that is basically it. We'll take the original number and compare it to the reverse number. And this will return true or false, which is what the method is expecting. And then we'll end the method. So now, let's debug this real quick. So I used the number 1, 2, 3 like we've been working with so far. First thing we're going to do is assign that reversed and store the num variable. And you notice down here is the 3 variables that we're working with, so you can follow along down there. So we're going to make a new variable called inRemainder and get the modulus from that. So that will take the 3 off of num, or get the 3 from num. And now we're going to put that 3 inside reversed. And then we're going to divide num by 10. So if you look after one iteration, num is out, now 12, so we removed the 3, we've stuck 3 in reversed, and we still have the original value. So let's keep going here. Now we're going to take out the 2, we're going to add this, so we're going to have 3 times 10 for 30 plus the remainder of 2 to get 32. And now we'll take off the 2, so again down here, we just have the 1 left, reverse number is 32. Final time, we're going to take the 1 off, add it to the reverse, and remove it. So now num is 0. And it's going to break out of this loop. So now we're just going to return, is the original equal to the reversed, which it is not. And so it should return false, which it does. All right, now let's take this back to LeetCode and run it. Look at that, accepted. I love it. Now let's submit it. Look at that. We are the fastest submission out there, faster than 100%. We are good. All right, the last thing I want to go through is the space and time complexity. So time complexity measures the time it takes to run the algorithm. And because we divide number by 10, every iteration we have a log base 10 of n. Now this is called logarithmic complexity. And basically it says as you drastically increase n, it's only going to barely increase the execution time, as shown in this graph. And space complexity is the total amount of memory that an algorithm or operation needs. And this is just big O of 1. It's just going to take the same amount of time to compute despite the size of n. And this is what's called constant complexity. It doesn't matter how big the integer input is. It's going to take the same amount of space. And that's it. So again, thanks for watching. Good luck on the interviews, and we'll see you next time.